Hi, I'm Dave Maynard, and now we're going to talk about the science argument. Before we do, though, we've got to define some terms. Oh joy! Let's define what science is. The word science comes from the Latin word scientia, and I hope I'm pronouncing that right. And it means having knowledge or to know. Since the modern scientific revolution from the mid-16 or 1700s on, science has become a way of knowing or discovering the truth about the physical world around us. We can discover this truth about something by two methods. The first method is called the scientific method. Another word that some scientists use is operation science. And that is where we can perform observable, measurable, and repeatable experiments in a controlled environment to find out certain things about our physical universe. Because we can measure these physical things, and because we can repeat the experiment, anybody can repeat it, to get the same values, this method is almost always 100% accurate. But to use it, you have to be able to observe an event, measure that event, and then repeat the observation and measurement. And that would be anybody could repeat the observation and measurement and get the same results. Then we have a method that I'll call origin science. It's also called the legal historical method, and that is for events that are non-repeatable, that we can't observe them, we can't measure them, and we can't repeat the experiment. So what we have to do there is examine reliable testimony and physical evidence, whether it be pottery, artifacts, canyons, whatever. This knowledge about past things or things that cannot be observed, measured, recorded, and repeated. Some science can be used in this method, but you can't use the scientific method to do it. What science do I mean? Well, like DNA testing. You could use that in a criminal case where you're trying to convict somebody of murder. Now, did you see the person murder him? No. And even if you have someone say he did, you can't repeat that. In other words, the jurors can't see the guy being murdered. So they would have to trust the eyewitness testimony of the person that did see it. So this origin method or this legal historical method, because we can't observe, measure, record, and repeat something, it's not 100% accurate. The only conclusion we might be able to make is where do all the evidence, where does that lead us to? What conclusion? Well, first off, is there enough evidence to lead us to a conclusion? And then what conclusion is it? So when it comes to history or legal matters, or even things that I would call the intangibles like love, trust, things like that, this is the kind of test we could use. We cannot use the scientific method. For example, I know my spouse loves me, but I can't scientifically prove that. Why? I can't observe it. I can observe the effects of it. She stayed married to me all this time. She has a very tender heart towards me. She supports what I do. I do the same with her. Those are the effects of our love. But love, it can't be quantified. It can't be observed. So things in history cannot be observed again. We can't go back and say, well, yeah, we see that George Washington was born and that he was a general and that he was the first president of the United States. No, we have to take the available evidence from history, put it all together and say, okay, we're pretty sure George Washington was born, that he was a general, that he led the Revolutionary Army, and that he was the first president. So the legal historical method or the origin method would be the kind of test we would use. Now, the next area we need to talk about are the different fields of science like astronomy, chemistry, physics, biology, etc. Now, to go into each individual area would take way too much time here, and I'm not qualified to speak in some of these areas. But I'm going to take examples from 2 or 3 of these areas. And again, check out the references that I've listed for further, more specific details. One further note, while science only deals with the physical 4-dimensional world, it doesn't necessarily rule out any other dimensions or other realities. It just can't be used to measure them at this present time. I do want to point out something that some people call scientism, and that's the belief that there is nothing in existence but our 4-dimensional world, length, height, width, and time. That if it doesn't exist in our physical world, it doesn't exist at all. The late astronomer Carl Sagan defined it this way when he said, quote, "The cosmos is all that is or was or ever will be," end quote. Scientism believes everything can be explained by the natural laws of physics and chemistry, etc. It doesn't believe in or give any credence to the supernatural or to miracles. It believes everything will eventually be explainable by science. Obviously, many of the people that believe in this are atheist. Other words for scientism would be naturalism or materialism. Any conclusion that doesn't have a naturalistic explanation to it is rejected by these people, even if the facts are leaning in that direction, or even if the preponderance of evidence points in that direction. So belief in God or an intelligent designer is rejected before you even need to look at the facts. The big problem is, how does someone like Carl Sagan know that the cosmos is all there is? To know that the cosmos is all there is, or that the 4 dimensions are all there are, you'd have to have complete knowledge of the entire universe, which we don't have. This is one of those statements that, while he said it and believed it, it's a self-defeating statement. It has its own destruction built right into it. We just don't have all the knowledge, so we don't know if the 4 dimensions we have are the only dimensions there are. We can say they're the only dimensions that we know of, but we can't rule out any other dimensions. In fact, some scientists are saying, well, there are more dimensions. They haven't proved that yet, but so it's critical to realize all scientists look at the same set of facts. They all do. The only difference is how they interpret those facts. And here's where the difference between hard evidence and soft evidence comes in. Hard evidence can be observed and measured. Soft evidence, again, uses the best available knowledge that we have and then makes assumptions based on that limited knowledge. Hard evidence is data that's extremely reliable. It's hard to disagree with it. Soft evidence involves assumptions or educated guesses that may or may not be true. Now, you can take hard evidence and say, well, this leads me to believe that this is true. Okay, but your conclusion is then an assumption based on the hard evidence. The hard evidence is just data. Hard evidence does not reach a conclusion, it's just data, it's just there. When you interpret that hard evidence, that's where you get to conclusions. Soft evidence is not nearly as accurate as hard evidence. Scientists saying birds evolved from dinosaurs, they're using soft evidence to prove this. They may have some hard evidence that is out there, but they will then interpret it to say, okay, but then we feel that this is where it goes. Again, they're taking available hard evidence and they're extrapolating on it by making assumptions in areas where they don't have enough hard evidence. Now, we'll look at just 2 lines of reasoning in this session. One is the finely tuned universe that really seems perfectly suited for human life. And then 2, we'll take a brief look at the incredible design of our human cells in our bodies and DNA. What I'd like you to do is please, please, please watch the introductory video that I list in your notes. Watch that first. That will prepare you for a lot of the stuff that I'm about to talk about. Now, according to astrophysicist Dr. Hugh Ross, there are 152 physical constants that are crucial to human life for it to exist on Earth. They range from the amount of oxygen in the Earth's atmosphere, or the right type of star that our sun is, or the right distance that Earth is from our sun so that water can be in the liquid state, because water is absolutely critical to our form of life. In fact, the distance that the Earth is from the sun, it's within what's called the habitable zone for planets in our solar system. Now, Earth is the only planet in our solar system in that zone. And that the habitable zone is where water can exist in a liquid state. The Earth having a magnetic field which shields us from the harmful radiation of the sun. Having the right size moon, it stabilizes the Earth's tilt, which gives us moderate temperatures. And I know you're saying, well, wait a minute, our temperatures vary a lot. Well, no, they don't compared to other planets. They vary from maybe -20 or -40 degrees to maybe 120 or 130 degrees, and that's it. And that's not much. That's less than 200 degrees, about 150, 170 degrees. On a lot of other planets, either the temperature is so hot or so cold that our form of life couldn't exist, or the temperature ranges can be in the hundreds of degrees or even thousands of degrees. So our moderate temperature also helps the ocean tides be bearable as they move minerals around. We have an ozone layer in the upper atmosphere, which protects us from solar radiation that would fry our brains in seconds. The ozone layer is less than an inch thick. Ozone is O3, oxygen is O2, ozone is O3. And when some of the sun's rays hit the ozone layer, they break it down into O2 and O. But then they recombine to form O3, so the ozone layer is constantly being broken down and reformed, but it's blocking out that harmful radiation. What would happen to us if that radiation reached the Earth's surface? Honestly, it would boil your brain in seconds. We could list many, many more of these constants, but I think you get the picture. There is a partial list of 34 of these constants at the website I gave you, and there's also another referenced website I list there also. But the probability of all of these 152 physical constants, and there may be more, but there's at least 152 physical constants, that the probability of them happening all by chance is 1 chance in 10 to the 282nd power. That's 1 chance in the number 1 followed by 282 zeros. Now, from an earlier lesson, remember, if you don't have 1 chance in 10 to the 53rd power, it'll never happen. That's what scientists have defined as 0 chance of happening. And remember, 1 chance in 10 to the 54th power is 10 times impossible. So 1 chance in 10 to the 282nd power, that's beyond comprehension. There are not that many atoms in the universe. There's only 10 to the 80th power atoms in the entire observable universe. Take one of those tiny atoms, mark it, throw it into our universe. What's the chance of your picking that one atom out? And that's 1 chance in 10 to the 80th power. 1 chance in 10 to the 282nd power is just, you can't even imagine it. I've also listed a reference for you in your notes about a very detailed list of these 152 constants, what they are, and what their chances of forming by chance are. So more and more scientists are beginning to say, you know, the physical laws and the structure of Earth and all of that, it's so fine-tuned for human life. Many of them are beginning to say there's no way this could happen by random chance. No. They are beginning to say somebody has tinkered with the laws of physics. They have made them so exact that our form of life can exist. That's where an intelligent designer comes in. And while intelligent design, there are a lot of people who don't agree with it at this point, every month more and more scientists are coming over to the intelligent design argument. A second thing I want to talk about is our body is made up approximately of 75 trillion cells. Now that's 75 with 12 zeros after it. And we have about 210 different cell types. Now the smallest cell size is 1/50,000th of an inch in diameter. You could fit 250,000 of those cells at the end of a period on one of the notes. Scientists used to think a cell was a very simple unit. They know now that this simple cell is far more complicated structurally than the most advanced factory we have in the world. In fact, it's more complicated than the most advanced city we have in the world. There are so many different parts in that cell that must come together at the right time and in the right place. Many of these parts have to be either specifically right or left-handed to even work. Even if one molecule is in the wrong place at the wrong time, or it's the wrong-handed one, let's say it's a right-handed one and it needs to be a left-handed one, the whole unit won't function. So here are some things to consider. Each cell is surrounded by a membrane thinner than the spider's web. And that's got to function properly. It's got to let certain things in and keep certain things out, or the cell's going to die. Each cell generates its own electric field, which at times can be larger than a high voltage power line. Each cell contains ATP, and that's the body's main energy source. It converts food into energy. Each of the hundreds of these APT motors, because it's like a small machine, is 200,000 times smaller than a pinhead. And it has a wheel on it that turns at 100 revolutions per second. Your body contains hundreds of trillions of these motors. Nothing we have ever created comes close to these motors in performance, durability, and size. Each of these ATPs are made up by instructions from your DNA. DNA is an acid. It's made up of proteins. Those proteins are made up from amino acid chains and nucleotides. There are 80 different amino acid types, but only 20 of these are relevant to cell life. So again, it's got to be the right type of amino acid. Amino acids are produced in equal quantities of both right and left-handed varieties, but only the left-handed ones are used in the DNA. Nucleotides are produced in the right and the left-handed varieties also, but only the right-handed ones can be used in DNA. This brings up a few of the many obvious questions. How could any specific left or right-handed component know when to arrive at the right place at the right time? How would all the components randomly know how to assemble properly? Where would the information for the cells to work together come from in the first place? That's got to be the biggest computer program that we've ever seen. Who wrote that program? And what would initially energize what we know as life? All of these things coming together are crazy ridiculous in terms of probability, but then you have to, somehow life has to be energized into that. All of this does the following depending on what type of cell is produced and how it combines with other cells. Each neuron has about 100,000 branching fibers connecting it to other neurons. There are about 100 billion, that's 1 followed by 11 zeros, 100 billion neurons in your brain alone. Your nose can differentiate 10,000 different smells. Your ear has over 100,000 motion detecting hair cells that allow you to maintain your balance and your motion. Yeah, and they're just little cells or little hairs in your ears. Over 100,000 of those can, depending on how, and they're all enclosed, but depending on how air moves over them, that helps you to maintain your balance and your motion. Your ear has over 1 million moving parts. In your eye's retina, there are 120 million little rods for dim vision, night vision, and peripheral vision. And there's over 7 million cones that help you determine light, and help you determine color, color and detail. Your brain has the capacity to store the amount of information, are you ready, in 25 million books. There are only about 20 million books in the entire Library of Congress. Your brain makes about 1,000 trillion computations per second. I could go on and on. There's so much more here that comes from just one tiny DNA molecule that somehow knew exactly how to build and maintain your body for what, about 80 some years? I mean, think of how many times your heart beats. I've heard that it beats billions of times in your lifetime. All of this is way, 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 way more complex than all the manufacturing factories in the entire world. How many of us walking into one of these factories would assume that the factory assembled itself by chance? And yet there are some scientists who think just that our body that is way, way, way more complex than the most advanced factory or all the factories in the world, and yet they'll say, oh no, you walk into a factory, well no, that was built by somebody. But they'll say, our body, no, it happened by chance or by random mutations. Some quotes from some leading scientists, I've listed them on your notes. Sir Dr. Fred Hoyle, British astronomer and mathematician, said the likelihood of life coming from non-life is 1 chance in 10 to the 40,000th power. There are several other scientists that agree with this. More scientists are coming to believe every month as they discover more and more about molecular biology. And more scientists are beginning to believe that there has to be some kind of an intelligent designer behind it. We can produce many, many more examples from biology, chemistry, physics, astronomy. Suffice it to say that I think science is gradually but slowly coming back to realize that there is an intelligent designer, or for another easier word to say, there is a God. Louis Pasteur, a Christian, said, a little science estranges man from God, but much science leads them back to him. Max Born, a Nobel Prize-winning physicist, and physics was my major in college, and so I know a fair amount about what Max Born did. He said, those who say that the study of science makes a man an atheist are rather silly. James Tour, a current nanoscientist right now, says, I build molecules for a living. If you study science, it'll bring you closer to God. Derek Barton, a Nobel laureate winner in chemistry in 1969, said, science shows that God exists. Anthony Hewish, another Nobel Prize winner in physics in 1974, said, I believe in God. It makes no sense to me to assume that the universe and our existence is just a cosmic accident, that life emerged due to random physical processes in an environment which simply happened to have the right properties. I've given you several book references. I've also given you several website references to check out everything that I've said, and there's so much more that can be said. I'm just giving you, I'm not even scratching the surface, I don't think. So I hope this has been enough to get your imagination up, and you can check out either these books or these websites, okay? Have fun checking them out. We'll talk to you next session. Bye-bye.